Good morning, everyone. I hope everybody's having a fantastic start or end to their day if you're not in this part of the world. So my name is Michelle, and we'll have today's June 29th SIG-Apps meeting. We have two demos. Can everyone hear me? Yeah, okay, cool, awesome, thank you. So let's go ahead and get started, since I think there will be some discussion also at the end. The first demo we have today is from Bart Spans, who has been doing infrastructure work at a consultancy in London. He's been specializing in container workloads, so he's been working a lot with Docker, Mesos, and now Kubernetes. And he's going to share with us a little bit about his project, KubeFuse. And Bart, I'm going to give it to you. Take it away. Tell us about yourself, where you are, and tell us about KubeFuse. Thank you.
Awesome. Thank you very much. Can everyone hear me too?
Yep.
Just going to share my screen. I've got a few slides from a larger presentation. I'll just get through that very quickly. Hopefully you can actually see this. Is that fine?
Yes.
Okay. So KubeFuse. So I work as a consultant in London. Yeah, I do a lot of infrastructure work. I've been doing container-based workloads for about three years now. So as a company, we work a lot with that. I'll just go very quickly. So this has been the last year for me with Kubernetes. And this will probably be the next year as well. Lots of interest from companies in London, which is why I started doing some tooling around it, and that's what KubeFuse is. So I'm gonna assume you all know what Kubernetes is. It's about pods. It's about replicating pods, exposing pods, using stuff. This is,
Can I mute their mic space?
There's someone, yeah, that's better. And then there's namespaces which allow you to group your resources logically. That's very nice, and it's also something we see getting used a lot at our clients. But the tooling is slightly awkward. So working with kubectl, there's quite a lot of typing. And quite a lot of run this thing first, and then take an ID, copy paste it, and run the next command. So I got a bit tired of that, which is the main reason of why I started developing KubeFuse. So KubeFuse, it's not so much a file system for Kubernetes as it's a file system view for Kubernetes. So basically a new way to look at what's going on in your cluster and to manage it. So why would you do that? Well, basically because the file system as an interface is quite familiar. It opens up like a huge history of Unix tools that are all very, very familiar. And there are some side cases where you can use it for backups and later even continuous deployment sort of ish. I'll skip all this. Sorry. So yeah, some things like it's easy to look at what's going on at your cluster, easy to troubleshoot, and it can even do writes. So you can update your resources using an editor, save it, and it will apply it in the background. Use it for backups, and this is more the experimental support. It's coming later, but if you've got multiple mounts, then you can copy between them as well. And it's just fun, basically. So yeah, this project, it started as a sort of weekend hack, and then it got some interest, and I got loads of suggestions on Twitter to add more stuff. So that's the result is basically this. But it's generally useful though, and you can read a bit more on our website about the actual implementation. But today I wanted to mostly focus on demos, so I'm gonna stop this. So I've got a little cluster set up in Google Compute. So we can use kubectl to get the information. This is probably familiar, so we can get the pods, but actually those are not all the pods because there might be namespaces, and there are in this case. So something I found a little bit annoying is when I wanted to, for instance, look at this pod. So first I have to type this, and then I can describe the pod and copy paste this, and then I still have to do this. A lot of the times I forget this word, or I forget to add the namespace again, and yeah, it's quite a lot of typing, which you can actually avoid by setting up a default namespace in your kube config. But I tend to switch between namespace a lot, and yeah, we have clients that use like 5 or 6 namespaces per cluster, so then it gets a bit unwieldy. Yeah, so that's basically the problem I was trying to solve. I was just so lazy, didn't want to type anymore, so I started creating this product, but it actually took way longer than typing all these commands, but it's just more fun, so that's why. So KubeFuse you can find on GitHub. It uses Fuse, which is it's a library consisting of 2 components. So there's one kernel component and one user space component. It basically allows you to implement file systems in user space. So we don't have to write complicated drivers in kernel space, but we can use Fuse to do it in user space. I've written it in Python because Python already had like a nice library available for it. And it also means, again, like we can move up in the abstraction layer. We don't have to deal with all the low-level details that much. Anyways, just to give you an idea, we can run KubeFuse from the command line. For the moment, we can only pass it like the directory you want to mount it on. My internet connection is unstable. Is this causing problems anywhere, or is this still fine?
It's still fine.
So I'll run KubeFuse here in the background so we can go back and forth between logs. And now, hello, I can go into this test mount directory and hopefully, oh, seeing nothing. That's not, oh God. I'm not quite sure what went wrong here. Ah, there we go. Ah, sorry, I think I was in a directory that didn't exist anymore. Anyway, so we're back in the mount. So in the root of the mount, we have the namespaces, so we can immediately go change our context for the work we're doing to the namespace. So in my case, I wanted to go to kube system. And then I can look at all the different resources there. So I can go to the pods. It takes a while because in the backend it still has to go to the actual cluster and fetch all the details. So it takes a bit of time, especially since my internet is a bit slow now. But doing it a second time is quick because there's quite a lot of aggressive caching going on, which I can talk about a bit more later if you're interested. It basically means because we're doing a file system, there's quite a lot of checks we need to do in terms of like how big our files are. Do these resources exist? What are the modification dates? So I don't want to go to the cluster every time to get that information. So there's quite a lot of caching going on, which means that the second time around it's a bit quicker. But then obviously that expires again. Wow.
We lost you.
On a bad connection.
There we go.
Keep them away in this game. So I'm just going to back out of this.
Lost you again. Did we lose Bart? I think we lost him altogether. Okay.
Yeah, he's not in the participant list anymore. So while we wait for him to come back, if he's able to, should we move on to the next demo? And hopefully
Yeah,
I can
that sounds like a good idea.
finish off. All right.
Okay, so next we have the DRUD team from New Media Denver. So who is here from there? Awesome. Okay, I see hands raised. Great. So go ahead and take it away. Tell us how you use Kubernetes Jobs.
Okay, can you hear me?
Yes, we can.
Alrighty. So my name is Aaron Corson. I'm here with the DRUD team. That would be Kevin Bridges, Brad Bowman, and Matt Tucker. You can see them in this table video up here. Maybe you can't see it. Pointing in a weird direction. Anyway, so DRUD is a Drupal and WordPress management platform built on Kubernetes. We're using jobs basically to replace Jenkins and Celery from our previous code base. It takes several parts. One is a REST API we call DRUD API, and the other is a service called Job Watcher, which works inside of Kubernetes. So so we use the jobs in two specific ways. One is to sort of replace the automated container builds that you get from Docker Hub, and the other is to handle backups and restores to things like MySQL, MongoDB, and media sets, files and whatnot. So before we get to the demo, we do the automated container builds by first posting a container entity to our DRUD API. That then uses a hook to reach out to GitHub and put a post commit hook onto the repository. And from then on, every time you make a commit to the repository, it sends a post to our API, which kicks off a job. So the job is just a container we call build it, which clones down the repository, builds it, and then pushes it to the registry of your choice. Sometimes that's GCR for us, sometimes it's Docker Hub. The second way in which we use jobs for the backups and restores, you basically send a patch to an entity in DRUD API, and it reaches out, creates a job, which pulls files from GCS, and pulls them together. I don't remember exactly what it does after that, but then it sends a post back to our API, which kicks off further jobs. So through our REST API, we're able to add callbacks to Kubernetes Jobs, which is a feature that doesn't exist currently. When we kick off a backup and restore job, it reaches out to the pod that it needs to back up or restore. It can do that through, say, MySQL's ports or Mongo's ports, or sometimes it uses a tar pipe for files. So I think we're going to have a little demo of the container build, and I think Matt Tucker is going to take over the screen for that.
Yeah, let's see here.
All right, just audio. Should I mute this one?
Cool. So I'll go ahead and take over screen share here.
Should mute the mics on a laptop for all of them.
Let's see here. I want that, I believe. Cool. Can you guys see my screen?
We can see your screen now. Thank you.
Awesome. Basically what I'm going to show very briefly is the container build job that Aaron was just speaking about. So I've already basically added this small little container, which is just kind of a fun little game that I threw together. Well, not that I threw together the Docker container as just a demo. So anyway, I've already added this particular container to the DRUD API. So DRUD API is already tracking this particular repository, and we already have a webhook added that was created by the system. And then over on the left-hand side of my screen, I'm basically just watching for new pods. So if I just come over here to this container and just make a minor change to it with a couple line breaks, we will go ahead and trigger a new build, and we will commit that change. So this just basically sent the, whoa, okay, sorry. So that basically just sent the commit to GitHub. GitHub sent the webhook directly back to DRUD API. DRUD API then kicked off this Kubernetes job. If I just take a quick look at the logs of this job, actually it's already finished. And this is one feature of what we have running called Job Watcher. So we have a small little pod running called Job Watcher. Job Watcher basically keeps track of all of the running jobs on the cluster and their current status. Once a job completes, it basically ships that status and all of the logs back to DRUD API so that then we can react to the success or failure of that job. After it does that, it basically deletes the job to completely delete all the pods from the cluster. So at this time, we already have done this, and I'll actually go and make another commit just so we can actually watch these logs go through. I'll be a little bit faster this time. Commit changes. So yeah, we can basically see that it's cloning down the repository, it's doing the build, it's doing the tag, and it's doing the push. And so that is now on GCR, which I could go pull down or run if I desired. So that's just one example of how we're using jobs. I think it's important to say that jobs can be used for a number of different purposes, parallel tasks or large computational tasks. We're using jobs simply because they are short-lived pods and things that we needed to run and possibly retry, and so we're able to basically use that capability of Kubernetes jobs to continue to retry these and for a certain amount of time before it completely gives up. So another reason we use jobs for the backup and migrate. As Aaron mentioned, there's the two main reasons we're using jobs. One was this build it that I just kind of demonstrated. The other is database backups and restores. One of the main reasons we picked jobs for that particular task was because of the upcoming scheduled jobs features. And we need the ability to schedule those backup jobs. So those basically connect to take a certain number of parameters. And in fact, I can show a quick example of what that looks like. Just a quick example of what one of these jobs looks like. So these are all written in Python just because it was the language of choice at the time. They basically just run the Python file and pass in various different parameters that help this job determine exactly which database it needs to take the backup of. Once it does that, it uses the MySQL CLI to connect to that database and just run MySQL dump. It tars that up and pushes it right to G-Cloud storage before the job completes. So yeah, that's a brief demonstration of how we are personally using jobs. If anybody has questions about that, would love to answer them. There's certain parts of this that we can probably open up over time. But I think more generally speaking, it's just the pattern that we're using that's probably interesting here. That creating jobs programmatically and then programmatically responding to the job's success or failure. And possibly creating follow-up jobs depending on if the job was successful or failed. So yeah, that general pattern has worked really well for us. But I think that's basically the bulk of our demo here and conversation. So if anybody has any questions, we'll gladly take them.
I believe you have a question in the chat.
Oh, let's see here. We're gonna get to that window.
Is the
right
job
here.
watcher?
Matt Butcher says, is the job watcher pretty generic? That's a piece I could definitely imagine using in my own stuff.
Yeah, so that's a piece that we did open source, and I'm sure Aaron's going to paste the link to the chat room right now. And basically, the piece that we open sourced is just the watching of jobs themselves and some of the thresholds. The little bit of code of what to actually do when a job completes or fails, Job Watcher just kind of leaves up to the user's choice. Right now, it just basically deletes the job. But you can do with that information whatever you want. So we basically open source the little generic piece that we could, but given the DRUD API that it ends up sending all this information to, can't currently be open sourced. That piece is definitely a little bit custom addition to the Job Watcher code.
Awesome, thanks. Does anybody else have questions? I'm curious, is anybody else on this call using Kubernetes Jobs in a similar manner, or using jobs at all? Aaron, you're using jobs, right?
Yes, we
You wanna
use
talk?
jobs for a few small tasks on the Deis team.
Cool. Is it pretty similar to this, or how does it differ?
We've used them, most recently we've used them to do some load testing on our internal logging system. So generally speaking, we would spin up a job with a lot of parallelism, and each pod associated with that job would use the boom program, which is basically a Go port of Apache Bench, and that would produce a lot of HTTP requests on something. For us, we used a deployed app, and that in turn would generate a lot of logs, and that in turn, after generating a lot of logs, would test our logging system. And then once that happened, we would be able to test, how many logs our logging system could generate. Once the job was done, the difference that we took was we left it running so that we could examine the logs of each pod. But that became a little cumbersome. So something like the Job Watcher would be very helpful for us so that we could ship logs somewhere else instead of having to do a manual kube control logs.
Yeah, that was definitely one of the main reasons that we wanted to write Job Watcher, was simply so that we could ship those logs and the status of those jobs elsewhere and react to it, and be able to serve those logs to the end users or whatever it might be.
Awesome. Does anybody else have questions? Last chance for the DRUD team. Okay, cool. So Bart is back on.
Hello.
And Bart, do you want to just kind of pick up? We still have a few minutes left for this meeting.
Yeah, very sorry about the dropping out. I never had a demo gone so wrong. I actually left the meeting, so that's a new one. But yeah, we're back, hopefully. There we go. So we have the pods here. We can CD into each pod.
Share your screen.
Oh, sorry. Sorry about that. How's that?
Awesome. You can see it now.
So we've got the pods. We can CD into a pod, and in there we'll have a number of files. So we can get all that information out. So we can look at logs. Nothing there. We can also export the whole thing as JSON or as YAML. Yeah, there's just some small usability things. So the thing I want to show as well was how we could use this to make modifications to a cluster. So for instance, I want to scale up the number of replicas here. Which means I can just open it in like a good editor like Vim, modify the replicas, save it, and that in the background we can look at the logs here. This is a response from Kubernetes. It actually has applied the change already. We can double check that. Oops. RC. I already go wrong here. in there, we have 2 replicas. So yeah, you can use it to make quick tweaks and modify your cluster on the fly. One downside there is when you make an error, there's not really a great way to communicate that back yet. So yeah, some of the open questions I have with KubeFuse myself is like I find it quite helpful for exploration and looking at logs. The writing things might be less practical. But yeah, it's like this mapping between what Kubernetes does and what a file system can actually do. So yeah, that's something I'm still like thinking about as well. Like, what do you do with when errors turn up? How do you create new resources? Is it a matter of creating directories, for example, and creating files, or do we still want to depend on kubectl for that? But yeah, that's basically it in a nutshell. You can have a look on GitHub. I'll post that link in the chat as well. Try it out. Maybe if you have some suggestions or questions, yeah, give me a shout. And that's it for me. Thank you very much.
Thanks, Bart. Does anybody have questions for Bart? Okay. Thanks. I'll put your contact info on the minutes. So if anybody does have questions, please reach out to Bart. Thanks so much. So the other item on the agenda is to talk about the SIG-Apps survey. Matt Farina is looking for volunteers to help analyze the data. Matt, do you have anything to add?
No, the idea is to do a blog post when it's all done with a roll-up of trends or anything else that was interesting in the data, and then to release the full data set as well, so anybody and everywhere can go poke at it. So I'm looking for folks to help look over the data and see what's interesting that we can find. Any takers, please let me know. And I'd like to get this done hopefully by the next meeting. We'll see. It might take 2 weeks. So, but let me know.
Awesome. Thanks, Matt Farina. Does anybody else have something they want to talk about? We have a few minutes. So does anybody have anything to bring up or something that they'd like to see in the future? I know jobs was a particular request from the last meeting. So if there's anything else, please speak up.
Hey, I've got a question. I'm Sasha from Gravitational.
Yeah.
What is the best way to participate in design and probably some work of Helm? The reason I'm asking, I've been looking at the Helm roadmap and development, and I've got particular questions about Helm and direction where it's going, and to see how it applies with what we are doing at Gravitational, kind of the work that we do. So what is the best way kind of to participate in that? And to give some context, what we're doing basically, part of what we're doing lots of work on complex deployment scenarios on top of Kubernetes that involves a variety of steps. For example, we deploy Spark, Cassandra, Zookeeper, Postgres, kind of variety of services on top of Kubernetes that involves very complicated deployment scenarios. So I was wondering, how can we kind of join Helm to make sure Helm can do what we need basically for Kubernetes? Does it make sense?
Yeah, absolutely. So we have a Helm channel in the Kubernetes Slack, and so the entire Helm team is really active there. So that's like the best place to go. And also just check out our issue queue, but we'd love to have a conversation with you about those complex scenarios. We also have a developer call tomorrow at, I believe it's 10:30 Mountain Time, so 9:30 Pacific. And I can reach out to you after and give you those details as well. All right, it's 10:30. Thanks for joining. Please join us next week for the next SIG-Apps meeting. We're still finalizing the schedule for that, but it should be finalized in the next day or two. So check out our community page on GitHub for that. Thank you for joining. Have a great day.